Good morning, everyone.
Yes. Yes, I've
So,
started the recording. Okay.
sure. By the way, you are all able to hear me properly, right? And see me? No
Yes, I
issues?
can hear you. Yep.
Okay,
Yes.
good, good. And yeah, I'll get started. We'll wait for others to join. What time is it in
Uh,
India now? 6 p.m.?
it's 6 p.m. here, so I'll just say more. Give us 5 minutes. I have already sent
Okay,
messages to a couple of folks. Okay,
sure, sure.
so let them join and then we'll start. Okay, so it's
Yeah,
six
no
five.
rush.
Yeah,
Yeah, no
yeah.
rush, no rush. Yeah,
6:10 we shall 6:10 we start for sure. Okay,
okay, sure.
it within next 5 minutes. Okay.
Yeah,
Yep.
sure. All of you go grab some tea or coffee or some food or snacks, whatever you want. We have the session for 1.5 hours, probably, right? And my goal is to help you learn the platform.
Yeah.
So,
I think we have enough audience more, so I'll take 2 to 3 minutes and then I will hand it over to you.
sure.
Okay. Okay.
Hmm.
Let me share my screen. Am I audible?
Yes, you are.
Yes.
We have a pretty good audience. Thanks, everyone, for joining.
Yeah. So this is a new group move that we have started for Pune location. Okay.
But it
So
looks
we
like a
are.
pretty good group. A lot of people are here. So I'm very happy to see them. The more spread the word, the more the better. I'm also going to be presenting, I think, next week as well.
Yes.
So yeah,
Yes. Uh, First of all, let me know once my screen is visible.
yes, it is. Praful.
Yeah, yeah. So, good evening, everyone. First of all, thank you so much for joining on evening. Okay, so it's India. You have joined on evening. Thanks to Mo also. It's morning for her, and she has still joined and she's taking session for us. So this is our sixth session for Microsoft Fabric user group Pune. I restarted this group in June because there was less activity around in Pune, and I wanted to have all the enthusiasts from Fabric, Power BI in this group, so that we can have these type of events. We can learn something new, and we can kind of grow as a community and learn different things from each other. So, as part of this official Microsoft Fabric user group for Pune, there is specific code of conduct that we have to follow. This is something which is shared by Microsoft, so I'll not take much time. I'll just take 2 minutes and then I'll hand it over to Mo. Okay, so these are the five principles that we have to follow, guys. Be friendly and welcoming, so listen with purpose, try to understand what the other person is trying to see. Be friendly and welcoming to everyone. Be patient with your questions, we will try to answer your questions, the speaker will try to answer your questions, I'll be there in the chat to help you understand all of these things. If I can provide any input, I'll provide input. If needed, I'll ask the speaker to answer the question. Be thoughtful of how people will interpret your words, so be very kind, be very clear on the question. Okay, let's ask questions relevant to fabric, let's ask question related to the today's topic. Okay, be respectful and inclusive, respect the difference in opinions. If someone doesn't agree to it, it's fine, there might be a different reason why they kind of not agree to it based on their experiences. And as I said, be open and curious, we are planning more sessions, we are planning more things, so we'll try to help you out there. Okay. Yes, and the last part, uh, not acceptable. So these are the things that are not acceptable. I will not cover or I will not go through everything. I'll just keep this slide for a minute so that everyone can go through it. Okay, these are the things that we don't want in our group. We are here to learn. We are here to uh, do sessions on these things, learn new things, grow. If you want to socialize, increase your network, these are the things that we want to do. Okay, so with that I will hand it over to Mo. So Mo is a senior seasoned professional with over 28 years of experience in the industry. She has experience in Databricks, she has experience in Microsoft Power BI, and she has experience in Fabric. So today's session is about real time intelligence. Okay, and how we can transform the data using Microsoft Fabric and GenAI. Okay, so with that I will hand it over to Mo. So Mo, over to you.
Thank you, Praful, and welcome everyone. Good morning. I'm so glad that you all could make it. And as I said, like try to spread the word. This is a learning for you. It's a community event, right? It's totally, I'm doing it because I love to teach people or I love to share my knowledge. And so, by the way, Praful, I try to access the chat. It is disabled. Is it possible for me to share with them links or something on the chat window, or will it not be possible for me to write anything on the chat? Is it possible to make me co-host so that I can also edit the chat?
For
I,
now I think at last moment it's not
no
possible, Mo,
problem. Okay,
but
that's fine.
we can share the
Okay.
post session.
Okay,
We'll
okay.
share the post
Okay,
session. Okay.
okay, okay. So, okay, I'm going to start sharing my screen, everyone. There you go. And today's session, I have, first of all, a little bit about me. This is me. And, let me go to the presentation mode so you can see. There you go. Yeah. So if you search me with this name, I'm actually based out of Michigan in US. So my time is 8:30, 8:40 right now. I'm in Northville, Michigan. I've been working as Praful was saying, I've been working in the data platform for the last 28 years. Since 1998, I graduated from India only. I did engineering in electronics and telecommunication from Indian Institute of Engineering, Science and Technology. I worked in India for about 1.5 years. Then I moved to US for work. And then ever since there, I've been here since 2000, year 2000. So it's a long time. And right now I work for Accenture Avanade. I think most of you know Accenture. Avanade is Accenture and Microsoft's collaboration. I lead data platform modernization for large enterprises, both for building out their lakehouse in Azure Databricks or AWS Databricks, or using Microsoft Fabric data platform for building out and modernize their platform. Okay. And I lead primarily data engineering team, but also data analyst, data scientist. My skill set, the core skills that I've been working with the Microsoft data platform for many, many years. Like I started with Oracle because that back then that was the mostly used RDBMS or relational database management system. And that was obviously we started with on-prem back in 1998, and then moved to Microsoft SQL Server. In SQL Server 2008, R2 came in. And then after that, I worked on many other platforms. And then now all Databricks and Microsoft Fabric, real-time intelligence. I'm going to focus on real-time intelligence, which is becoming more and more important for you to know, because as you can see that we are trying to, a lot of companies, everybody is building either this personal agent or enterprise agents, AI agents, right? So those agents needs data, your enterprise data. So you need to make sure that data is coming fresh and coming as quickly as possible to help enable business decision making for the company and harness the power of data. So we're going to see how we can do that. If you've heard about streaming, that is basically what I'll focus. Streaming in the sense as the data is getting generated in, let's say, anything connected to internet through IoT devices, we're going to capture those continuous stream of data, and we're going to process, we're going to learn how to do all of those things. I'm going to go to the demo mode, but there's also a little bit lecture slides. I don't know how many of you have actually already worked on Fabric or you are completely new. So probably there's a variety of experience in the audience, right? So we'll try to start from the foundation to give you a little bit, as what it is we are talking about, and then we'll expand on it. Because the time is so little, and like we only have about 1.5 hours or 1 hour, 15 minutes, and there's a lot to cover. If we can't cover everything today, I'm going to have future sessions where I can come in. Okay. So today I'm going to focus on Microsoft Fabric, which is a unified AI data and analytics platform. And I'm going to focus on a particular service within that, which is real-time intelligence. That is for streaming data or real-time data, like in a low latency data. And I'll talk about all those things. Next week, I'm coming back again for Azure Databricks topic, how to build agents. And I'll talk about those next week, okay? And I love to teach. And let me just go and change. This is my LinkedIn profile. I tried to paste this link, but if you search with my name, sorry, anybody is saying something? I think there is an echo. If you can please mute yourself, that will be really helpful. Okay, good. So this is my LinkedIn profile. If you search with my name, you can find me, huh? And feel free to send me invitation to connect with me, and I would gladly accept it. Okay. And if you go back, you can probably look at my profile and etc. I'm not going to bore you on those because this session is for you. As I said, like I do share, I do write, I do talk, I do have, like I've spoken to many day of data events. Day of data, you probably know, right? It's a basically, so this is the day of data. If any of you are not aware, it's SQL Saturday. In the past, it used to be SQL Saturday. Now it is day of data called. I do have my own dedicated, I would say, dedicated channel, which is day of data Detroit. And I also have another user group. This is one user group I have recently set up, and I'm going to conduct similar session as Praful is doing for both, regular virtual meetup as well as in person. Okay. And feel free to, when I send those meetups, I would share it with Praful if anybody is interested. Again, these are virtual, so I'm going to try to see if I can make a time where India can join. You guys can join as well, and I'll bring different speakers as well as I'll speak. So I'm a practitioner. I lead data engineering team, hands-on and leadership. I'm uh, also I love to teach. So I share my knowledge as I was saying. That's why I do all these things. And what else do I want to talk about? Yeah, I do have another user group which is on Databricks. I would like to share that one as well, real quick. I won't take too much time. This is my Databricks user group. It focuses on Azure Databricks, but Databricks sits on all clouds. And you can always join my group as well. I'm going to share these links with Praful. And thank you all for listening in. All right. So, with that intro being done out of the way, let me start with today's topic. So, I'm going to go here. Any questions so far? Let me just check. Any questions so far? We have 18 people. Thank you all. Feel free to pause me, or if possible, maybe hold off your thoughts, write it down, the questions, and I'm going to try to respond that, because when I'm sharing my screen, I can't see who is raising hand or has a question or anything. So I can only see it when I come back to this window. Okay. So I'm on the
Yep.
laptop. I don't have any.
Yep. In case if there are any questions, I'll collect them and then I'll pause you more. Okay. for
Sure.
that.
And yeah, sure. And then my goal is, by the way, one question I'll ask. How many of you are familiar with Microsoft Fabric and Microsoft Fabric Real-Time Intelligence? Is there a, like, any way you can communicate, like thumbs up if you know, or it's completely new, you don't know? Okay, yeah, raising hand is good enough. If you say like, yes, I know, then you can raise your hand. I just wanted to get a pulse. Pratik is saying yes. And let me see if anybody else is saying yes. Probably two of you, right? Three, four. Okay. Pratik, Praful, Shuhash, and Ramesh. And okay, so rest everyone is relatively new. So then I have to go a little bit introduction on the data platform, cloud data platform as well. Thanks those who responded. So basically, um, we are talking about Microsoft Fabric real-time intelligence service for streaming data, like data coming from your IoT devices. So think of it, we now drive autonomous vehicles, right? We have thermostat, smart meter everywhere, smart thermostat in our home. We have, anything that is connected to the internet can collect telemetry, whether it is from the ambience, from the environment, whether it is temperature, pressure, thermostat. It's collecting all those, telemetry, right? We call it telemetry, meaning it's a continuous stream of data, time series data. Like as, suppose think of your home as a thermostat or a air condition monitor or a heat monitor. That's the thermostat, right? So what it is doing, it's trying to capture the room temperature, and it's accordingly either turning on the AC or turning on the heat. And room temperature, pressure, and humidity, all of those things. Same thing if you think about any industry, all industry has this application. If you think about manufacturing, they have assembly line, like automotive. They have assembly line or any other manufacturing, even food manufacturing, right? So assembly lines, if you connect to IoT devices, these are IoT sensors, they're going to collect the telemetry, whether it is the temperature or from the ambience or how much heating of that particular equipment so that it can predict failure, right? So what's the goal of all this telemetry collection is to make sure that you are constantly getting a live up to the minute status of your assembly line in units. Like, all those telemetry is going to come in and you're going to process it and you're going to make sense of it and you're going to intervene. What would be the intervention? Suppose if you are a manufacturing company like a car manufacturer. I'm in Michigan, so it's a motor city. So let's say General Motors or Ford or Chrysler. They have assembly line, right? They have like in India, you have um, uh, Tata or all those companies, they have assembly line where these automobiles are getting manufactured. So in that assembly line, everything is connected to IoT devices. Those devices are collecting telemetry. So suppose the equipment needs maintenance, so it's not doing functioning well. Probably there will be some anomalous transaction coming in from those devices. Through that, you can understand, yeah, this is heating up too much. Maybe there is a problem with this equipment. Then you can intervene and you can actually initiate proactive maintenance or you can initiate even replacement if necessary. So that's the goal. And this is more your devices, or basically in physical world, you have all these IoT devices which are connected to internet. They're helping you or enabling you to be able to get the status of those, wherever it is connected to. So that's one source of this type of time series telemetry data. Why do we call it time series? Because it's a time based. Like as we progress, this type of data will never end, right? Suppose your thermostat in your room, they always are on and they are always emitting temperature and pressure and humidity from the room. And they will never stop until the thermostat is down, right? So it's like a time bound, like it's in a time series. Like suppose I turn it on now, it's going to go on and on and on. It's going to collect the telemetry all the way until it breaks down. So it's a time series data. Okay, so we're going to talk about that type of data. It can come from physical world, from these IoT sensors. It can also come from digital world. What do we mean by digital world? Digital world means basically anything is in, like your applications running on cloud, your infrastructure running on cloud, your systems, your logs. So if you know any software system, that always you create audit log, you create traces and logs, right? What's happening within the system in system tables and etc. So those are also telemetry of the digital world. Got it? So physical world, digital world. All those telemetry means time series data. What does log do? Log are basically continuously writing what's happening in your system, right? If say suppose you have a database management system and you have database infrastructure in cloud, Azure cloud, suppose. So you would like to know if the database storage is like, we have scalable infinite storage in cloud, but suppose like, CPU is pegging or it needs more auto scaling to be enabled or some sort of a database is having some issues, some problem, and it needs to be intervened. Those are also log telemetry, right? So those log telemetries, you can process, you can make sense of it. Similarly, suppose you are in Microsoft Fabric. Some of you know Fabric. What is Fabric? The name is that Fabric, it is Microsoft's unified data platform. So unified, why do we call it unified? I wouldn't call it just data platform. It's AI data and analytics platform. Like it gives you the ability to do all kinds of processing. And it is cloud, right? It is an Azure cloud. Okay. So historically, Microsoft started with all kinds of data platform services, right? And AI services. So they had SQL Server, which was the predominant RDBMS. Then a lot more services came up, right? We had, as part of SQL Server, we have SQL Server Integration Services, which is the ETL processing in on-prem. Then SQL Server moved to cloud and became Azure SQL DB or SQL Server on Azure VM. Those are all SQL Server running in cloud Azure. And also you have your data factory, which is the cloud uh, cloud version of SQL Server integration services. So it's giving you the ability to ingest data. Then you had Synapse, which was another service for data warehousing, big data processing. Then you had Azure Data Explorer. That was the oldest service name, or that is still there. It was for this type of telemetry time series data processing. So Microsoft used to use that service or is using this service for all of their global cloud infrastructure. So Microsoft is a large global company, right? It has cloud data centers in so many places, parts of the world. And it's supporting this cloud infrastructure, right? So if you think about it, like Azure Data Explorer is the service Microsoft initiated almost more than a decade ago to monitor the cloud infrastructure globally. Why do they need to monitor? Because they have SLA requirement, right? You have to meet uptime for the databases, for VMs and whatnot. So those infrastructure, cloud infrastructure monitoring, and also security monitoring, like Microsoft has security product like Sentinel, log monitoring, all of those also security monitoring. If you think about it, how do you detect security issues? Because suppose everything like you detect anomalous transaction, right? If whether it is a SQL injection or some sort of a threat, how would you detect it? And if you get the data continuously coming in from your system logs, and at some point it shows some sort of anomalous behavior, that means that's actually like that's how you the system knows or Microsoft has been monitoring to understand this audit log to see if there is any threat or security issues or breach or anything, data breach or any security incidents that might be occurring or might be happening, etc. So Azure Data Explorer is a standalone service which has been used for more than a decade, as I said, for these type of streaming data. And we call it streaming. Why streaming? It's almost like a stream of water, like it never ends. It's like stream of data coming in. So that's why you call it streaming. Now, you probably are very familiar with batch data, right? Batch data meaning what? You're like batching them, right? In the past, we always used to like write the job, run the ETL every night or during after hour when the database is least used, so that all those insert update delays can happen without, people are trying to read the data at the same time and whatnot. So that's kind of batch processing. For batch, what you do, you accumulate the changes and only process it in a schedule at after hours and weekend. So it's like not fresh. You have to wait till next day's batch in order to get the fresh insight in your analytics platform. Suppose you have an operational, like a portal front end suppose you are all companies have their, presence in the world with their, portals, right? Or basically websites. So from there, you're collecting, clicks. So think of any Amazon, everybody uses Amazon, Walmart, everybody uses Walmart, or in India's version of those, right? So when customers are coming and clicking different items or checking different pages, those are click stream. Those are also streaming data. You want to get those and you want to understand your customer. Okay, what are they trying to buy? Which products are actually selling well? Or how can I sell more to the customer by combining or suggesting some more associated products to what the customer is actually selecting and putting in their cart. So those are also streaming data if you think about it. Okay. So like I'm trying to help you to understand how to differentiate between streaming data and the batch world, as I was talking about, is if you don't process that data that is getting generated and just wait for it to be written in the database, the backend database for that particular portal, and only process it when I say process, meaning what? Basically, what do companies do? They sell product, sell services, and just get more market share, get harness the power of the data or their own data that they are generating through these transactions with the customers, and then be able to make better business decisions. So the faster you get the data from these type of systems, the faster you can understand and pivot and steer it to it. Suppose you are saying some of the products is not selling well, or your web page is not very well designed and it's not very well received, and it's causing you, like you're missing your customers, or you're basically losing your customer for some reason. So the moment you detect all these things, you want to intervene, right? So that's why you need fresh data. Also, now we are in the age of agents. If you are building agents, like if you suppose you created a chatbot, okay, for customers to ask question, and you want to see what kind of interaction is going on between that customer and the chat response, like what is the chat it is responding. So all those go back and forth the conversation, you would like to also process and mine that, or basically in read that and see if there is any kind of fraudulent transaction, or any kind of a threat, or anything that should be, or uh, can cause legal issues for you. Like you can process those. That's again another streaming data, because those type of chatbots are always on 24/7. They're not humans, they are agents, right? They're sitting there to respond questions, and anybody can ask anytime questions. So hopefully that understand you understand what are the different ways that streaming data can generate. Now that we are in the age of chatbot, everywhere there is so many chats. Every company has created their own chats. Those interaction with the audience also has to be understood, processed, mined. And if you think about data warehousing back in the days, what do data warehouse was built to do is to understand what's happening with the operational databases. Like operational data means the data that is capturing your business transactions and an operational system. But operational databases are actually, most of the time, they're backing maybe front end portal, and they need to be very, very efficient, fast performance for insert, update, delete. Because if a customer is initiating a purchase, you want immediately the transaction to be reflected, right? But they are not for analytical use. Meaning, I would say, like normally, historically, operational databases will have a performance hit if you try to do analytics on top of the same data at the same time, because analytical workload is a read, operational workload is a insert, update, delete, right? You can understand. So what used to be is that you bring the operational data into an analytical data store as a nightly batch, and then you create kind of a data model in the analytics store, kind of a star schema or snowflake schema kind of data model, so that you can have that data, historical data, used for for improving your business, or for getting insights from the data. So that's basically your analytics platform, right? So now what we will see is you can also capture these operational data's change data capture, like CDC we call it, into analytics platform as a streaming fashion. Like as soon as a change happens in the operational data, You want to capture it and bring it to the analytics so that you don't have to wait for a batch window like nightly. Because batches are gone other days. Because the more fresh data you get, the more you can beat your competition, you can take faster decision, you can make better business decisions. Bottom line, you can build these agents. They are going to be more optimal, more accurate in their responses, because the more stale the data is, the worse off you are. Okay, hopefully it makes sense. Now I'm going to go a little bit faster. Now I gave a lot of background as what kind of data and whatnot. Let me now go to the PowerPoint slides. And I won't bore you on the slide. I'm going to jump to the demo very quickly, because I know it's very easy to understand things by looking at what's actually happening. Okay. So my title of the talk is, it's, I think, Praful published our title, which is very similar to this, but basically it's the same theme. We are talking about when we are getting these signals, meaning the time series data, how do we act on it in a timely fashion? When I say timely fashion, meaning low latency, as fast as possible, in the range of seconds or hundreds of milliseconds, or minutes also is fine, but not in the range of hours and days. Okay, or it's possible that you might have some systems which are not generating data as fast as in seconds. Those also you can still capture with the streaming with these type of services, because this is more for event driven architecture. So if you're scheduled versus event, I want you to understand that part also. What is schedule? Schedule means time bound. You are scheduling a particular process to run on a particular time of particular day or week or etc. So that's like a fixed schedule. What is event driven? Event driven means something is happening as an event, and that is automatically triggering the pipeline. So this type of architecture is also for event driven processing. As soon as an insert event is happening or an update event is happening in the operational data, you want to bring it in and trigger the analytic pipeline or real-time intelligence pipeline and process it and make sense of that data. Okay, so two things. One is low latency. Latency means how fast you respond. One is for low latency use cases, like mining these logs from your applications infrastructure, from your IoT devices, and from your agent conversations. The other one is event driven, like your operational databases, sending the insert, update, delete transaction as change data capture. And as soon as they happen, you want them to come flow it through the pipeline, come to the analytical store, and then be able to use it for your analysis, whether it is predictive analytics or historical analysis and whatnot. So that's that from signal to action. And we are going to see many services within Microsoft Fabric real-time intelligence. This is the service which is for streaming event-driven architecture. Okay, and we are also going to see Fabric IQ. Fabric IQ is another service or workload which is for building out semantic model, building out that knowledge graph, which will help these AI agents like data agent and operation agent to make accurate, answers or response actions or recommendations, to give responses which are grounded to your data and which are accurate and also cost effective. So I'm going to go detail on those very soon. But IQ stands for intelligent, right, quotient, right? That's what we think. So within Microsoft has rolled out 4 different IQs. So Copilot is everywhere. That is your AI power to enable you to get the power of AI wherever you are working, whether it is your Teams or your Outlook or your Word document or your PowerPoint or your Excel and whatnot. So that's everywhere. That's AI trying to help you as an assistant. This IQ, this Fabric IQ, is within Microsoft Fabric. It will enable you to get intelligence out of your data estate within Microsoft Fabric. And as I said, Fabric is a unified data analytics and AI platform for the era of AI, meaning it is ready for these agent building and AI using for utilizing the power of LLMs and be able to get intelligence out of that data estate that you have within Microsoft Fabric, which is in cloud. Okay, so what Microsoft did is, as I was telling over the like historically how it evolved for all the different services. So historically, there were SQL Server, there were Cosmos DB, there were Synapse, there were Data Factory, there the Azure SQL DB. So they were kind of disconnected service, and Azure Data Explorer and whatnot, Event Stream, streaming analytics. So there were different services for different workload, and they are kind of disconnected. And companies have to come and integrate because you want a unified data platform, particularly for AI. You don't want your data to be stored in like this separate database, different technology stacks and whatnot. So that's the reason what Microsoft did. It combined or integrated all of their dis- different disconnected services into a unified, interconnected, ecosystem or unified layer, such that, and it's also made it as low code, no code, meaning software as a service, meaning you hardly have to write any code. You can use it like a for business friendly, right? For business practitioners who are not really, and not even for business practitioners, for everybody. That's why it's very easy to learn. It's very easy to use. It's also very easy to develop. But that doesn't mean that it is not having all of those traditional features like CI/CD integration to Git repository, code promotion. Even if you are, all of those are still there, or everything is available within the unified data platform, but you get that benefit of software as a service through Microsoft Fabric. And real-time intelligence is one of the workload, which is nothing but Azure Data Explorer in the past, which is enabling you to do that streaming data processing, event-driven data analysis. Okay. And Fabric IQ is the intelligence layer on top of your Fabric unified data platform. Okay. And there are other IQs like Work IQ, which is M365, all of your Office product IQ. There is a Foundry IQ and there is a Web IQ. Okay. So I'm going to skip those and focus on a Fabric IQ and real-time intelligence. And as I was mentioning, it is real-time intelligence is for getting data as it is getting generated to get insight from it and to act on it, right? So that's why it's also focusing on operational analytics. It's not just historical analytical analytics, but how do you make sense of the data that is in motion? Like as the data is generating and going through the pipeline, just like water goes through the pipeline in your house, like going through the pipeline from the pipeline in the sense processing pipeline, you want to immediately act on it and make sense of it and be able to harness the power of it and use better decisions for better decision making. Okay. So I think a lot of all these things I was mentioning simply because the audience, you don't have that experience. And Praful told me that they're starting from base, so start with foundation. Hopefully this was helpful. Huh? I normally don't cover these in this session because it takes a lot more time. So, and as I said, why real-time intelligence? See this word real time, meaning it's low latency, meaning almost instantaneous, but that doesn't have to be. Like it can be as low as milliseconds or seconds or minutes. It can also be event driven. As I said, like an event is happening. Suppose in your cloud infrastructure, there is somebody created a storage account, somebody created a workspace item. Those are events, a creation event, or a deleted something, or change something. Those events can trigger a transaction to come in or telemetry time series data. So it's event driven architecture. It's low latency. And how do you get that intelligence from that kind of a data, faster data, so that you are not living in the world of batch where it's happening only in the after hours and, as a like a batch window or a batch of data getting processed. Rather, as the data is flowing and getting generated from these sensors, from these applications, from these logs, you're making sense of it and getting intelligence out of it. So use cases just for your benefit. As I said, low latency, right? Typical latency where it is seconds range, milliseconds range, minute range. Think of banking application fraud detection. Very time sensitive. You have to intervene right away. That's an application. Think of patient monitoring. When the in hospital, like patients are wearing, let's say, Holter monitor, or some sort of a monitoring for to capture their blood pressure or heartbeat and all of those things. Those are again time sensitive, right? If a person is undergoing some sort of a like a cardiac arrest, you want to immediately intervene, whether it is send ambulance or send doctors and send the patient to the hospital, etc., etc. Those are time sensitive, so it makes sense that, right, anytime you see that there's a sense of time urgency, those are use cases, very easy to understand. There is also IoT insights like clickstream event coming from your websites, or your Fitbit, Apple Watch, all of those type of wearables, anything that you wear are connected to the internet. Your Alexa, your thermostat, your autonomous vehicle. Okay, those are all IoT applications. Customer service experience, as I said, like click event stream that is coming from your website. Customer analytics, again, you want to do analysis of customer behavior, customer segmentation. Those also down. They like, as the customers are navigating your portal, you want to behave, capture their telemetry, capture their clicks, capture their impressions, and then be able to analyze and be able to make sense, like what is it that the customer wants, how can I segment these customers. Those are the social media analytics. Like if you think about LinkedIn, X, Metas, Facebook, all of those, or all the other, Instagram or Insta, all those. I don't go there, but anyway, so social media sites, people are posting, right, and they are getting likes, they are getting comments, blah blah blah. That's also social media analytics. Like, why is it needed? Want to understand the sentiment of these particular users, and also to sell more products, right? Based on the user preferences, maybe an advertisement will come. And for that, the companies are willing to pay because they want to capture the market, capture the, sentiment of this, or the feed of this, vast people that are using these social media sites, and be able to make them more use it and make them buy product and etc. Analytics dashboard also, like if you have a dashboard you created for your company's leadership to make decision, or for your customer, that data is coming off of your operational data. So operational data to analytics platform through streaming, and then refresh those dashboards instantaneously or in low latency fashion, so that you get a up to the minute structure, like a kind of a control tower visibility of what's happening within my operational databases or not. And business intelligence, like you want to get intelligence out of your historical data. So literally everywhere. The only thing is, batch world is moving towards streaming world because of so much of focus on agents, and that is the reality of the today's world. Like there will be more and more agents. No one can stop that. If you can see the power of these LLMs and that harness the tooling around it, it is inevitable. It's happening. It's already happened, and it's going to more and more advance than that direction. So obviously, this type of data processing is something very valuable for all of you to learn for future, or for now. Future is here. Okay, so signal to action. As I was mentioning, signal means that capture that temperature. Suppose like this Apple Watch that I'm wearing, it's capturing my movement, right? When I'm walking, it automatically knows. When I'm running, it knows, on etc. Right? So that is again capturing from my body. It also can capture the maybe my heartbeats and blood pressure, or I don't know, whatever the power it has. So those are the signals. Okay. So I'm going to take the example of fleet management system. Suppose think of a company like, where is in India, there are many delivery companies, right? I don't know which companies are in India, but I'll give you the example of Amazon because it's easy. Everybody knows Amazon, it's everywhere. So Amazon's fleet delivery trucks are roaming around, right? These trucks are carrying the goods that needs to be delivered in a timely fashion, and these trucks are also connected to like the engine, the driver behavior. Like if you think about this autonomous vehicle, Tesla and so many other, GM, Ford, everybody is bringing this electric vehicles and autonomous vehicles. What they are doing is they are connected to internet through these devices, right? So in this example, I'm going to think of a delivery operation, a global delivery operation. Delivery trucks are moving around, they are connected. We are capturing their battery temperature, brake temperature, driver behavior, all other, telemetry from that truck or delivery truck. And we are ingesting it, and we are going to understand how they are functioning. Not just that we are capturing telemetry from outside environment, like weather. How is the weather fluctuating traffic condition? How is the traffic condition in these routes of those vehicles? Do we have to modify the route for a particular vehicle or suggest them to go to a different direction? Just like when you use Google Map or Apple Map and all those things, the GPS location is telling you if there's an accident, you go to another. So you're basically capturing this telemetry. Or if you order an Ola or a Uber or a Lyft, you can see how the car is moving, coming, how it is coming to you, and then it's reached exactly where you're located. So again, these are capturing telemetry put through GPS, and very similar situation. In this case, we are going to see how we can capture these signals and act on it. So signal is those telemetry. Reason means how do I know what is a, when do I have to act, like intervene? So, like I'm wearing this Apple Watch, right? So if I am having some sort of a health issue, the if this Apple Watch is in a series which can detect those things, then it can immediately, maybe it can even have the power to, you know, send an alert to call 911 or send an ambulance. Or if you think about a vehicle, like I one time I had an accident and it automatically calls, it has OnStar. It was a GM vehicle, and it automatically tried to call, police or 911 to send some emergency dispatch vehicle come there. So those type of things, like basically in this fleet operation case, what we are trying to intervene is all these fleets are moving around. Which fleets are actually having some sort of a malfunction? Whose routes needs to be adjusted? Where the weather condition is bad and that needs some intervention? Those type of things. So what you want to do, you want to reason off of that telemetry to see what conditions are actually and needs some sort of action. Okay, action in the sense, suppose this is your telemetry of the conversation between your chatbot and your users or your customers, and as you are ingesting this and you find some sort of a discussion happening between a user and the chat, which is totally irrelevant to your product but something related to harmful for humans, you immediately want to intervene and you have to say no, this type of transaction. Of course, you use guardrail and whatnot for your agents, but you also want to intervene with respect to like maybe stop that chat transaction or stop that chat session or something. So you understand. So those type of reasoning in the sense, how do I, or a manufacturing company, the equipment starts malfunctioning, hitting up. I want to intervene as soon as I see some huge spike on hit that there is something going on. Stop, like order a replacement vehicle, trigger a downstream pipeline, notify the supervisor on the factory floor, something like that. So that's that combination of signal that we will need to understand to see whether that indicates that this driver is actually having sort of a, so maybe the driver is not driving properly, it's taking a lot of risk, or maybe it's trying to rush, something needs to intervene, or the battery and brake is so high, so heated up, that the truck is probably going to slow down and it's going to have some delay. So what do? We want to send a replacement vehicle. So that context is, so that's that reasoning layer. Context is what? Context is additional contextual information. Like the signal carries information, like this telemetry that has some data points, but then that's not enough. You need more details to it. Like what? Like in this fleet operation case, like which fleets are in a high priority route. I only want to focus on high priority. I don't want to focus on every signal. Suppose you are a database administrator and you have set up some alert like failure or log, like anytime there is email is going to, you are going to get a page or you're going to get a text message that something needs to be done. You don't want to do it for every possible incident. You only want to do it for very high critical, like where the database is down, something like that. So that kind of, like, you want to get some additional context to it to um, to to see which ones you need to act on it, or incidents, security incidents, you want to detect it. And in this vehicle case, the context would be like, what routes are high priority routes where I have a really, very important, if I don't, if those vehicles slow down, then those delivery trucks slow down, then there is some reputational damage or maybe a loss of business, something can happen. And then depot, like your when you suppose FedEx or UPS or USPS in, I don't know what company in India, but basically these type of deliveries, when you have different services like premium, instantaneously overnight, though they cost you more money and they are high priority, right? Similar thing. So depot, like, and then what else is needed in this particular sentence? Like, what are the different possible depots for where we have delivery trucks sitting there? Like, why do I need to know that? Is because if a truck needs to be replaced, I need to know where is the nearest depot where I can send another truck from. So, okay, so that's why the depot. What are the different replacement vehicles I have in each depot? This is not that signals. The signal doesn't have that data. The signals are coming from those IoT devices, from these vehicles. But this additional contextual information is also, let's say, coming from batch mode or through to Lakehouse. Lakehouse is again another, like within Fabric, you have real-time intelligence. It stores the data to event house. 9:30. I am just looking at the phone time. I'm going a little slow because I'm telling all these things, but I guess I'll have to jump to the demo very soon. So that's that contextual information. That context is gives, like, without context the signal means nothing. You need more details which is coming from data other sources. Okay, and then with all of those you want to make decision is what in this case, like, recommend the next best operational, whether it is this vehicle needs to be replaced, or this driver needs to be changed, or this vehicle needs to be routed to another direction too, because the weather is bad, the traffic, there's some accident and whatnot. And then that action part is again human in the loop always, because we don't want, and so the decisions, like how do we automate these decisions is through agents. Like, you don't want human beings to sit there 24 by 7, that's and monitor and then do it manually, right? You want to automate this processing. Like, that's why you are going to build data agent. Data agent is in that processing. Data agent is basically um, getting all these incidents coming in, or the telemetry coming into event house and lake house and to the ontology, and based on that it's going to say, okay, this is the recommended action, this needs to be done. And then it doesn't automatically do it, because you will have to give it allow in order for it to act. Or you can say, no, I don't want the agent to do any action on its own. I want it to just message the person who is responsible, and then that person is going to review, and then that person will say, yes, I approve, I allow, or I don't allow. Accordingly, it will initiate the next step, whether it is to dispatch a vehicle, to trigger a pipeline, to do whatever the corrective action needs to be done. So basically here in this case, as you can see, we're not just, we will see visualizations. I know most of you are Power BI people. Power BI is actually the most, widely accepted reporting tool for analysis and for complex report design and, dashboards and whatnot, right? But in this case, the goal is not just to be on that once, like, just visualize the data and process it after the fact. Rather, you want to intervene when the data is getting generated in the operational system, in the physical world and the digital world, and act on it immediately. And in the process, you also do visualization. You can use Power BI, you can use real-time dashboard for visualizations for this type of data. So this is the architecture. And you are going to ingest the data. So Praful, I guess we have about 30 minutes, right? So I think we will have to
Sure.
continue this. Mhm. Yeah,
Yeah, you
we'll
can
have to
jump to the demo and then we can come back to the slide also. That's also fine.
okay. But otherwise, we will have to plan for more sessions. So let me just go to the demo then, as you were
Sure.
suggesting. So this is Microsoft Fabric. And it's, as I said, it's cloud native. When you go to, when you log in app.fabric.microsoft.com, you can get these options. Okay, Fabric, Power BI. So suppose I go to Power BI. By default, it's going to show you Power BI. See, Power BI it's opening up Copilot window, and it's telling what are your existing reports, etc., etc. Right? So instead of Power BI, I want to switch it to Fabric Persona. Okay, so that's this Fabric. It allows all kinds of workloads. You can bring the data to Lakehouse, you can build warehouse and whatnot. So I'm skipping all those. I'm only going to focus on streaming data, real-time intelligence. Okay, so I have a workspace created. Workspace is nothing but collaboration area for multiple people to work together for a project or a program or a particular initiative and whatnot. So I have this workspace. Huh? This workspace, I have multiple different folders also. So they may let me go to the list view. So the workspace, you can create folder. Within each folder, you can have all of your services, organized. Okay, this is more for organization. Okay, organized. So all the services that I've created is here, sitting in this particular folder. Okay, so this is the list view. This is the lineage view. Okay, so what are the services I'm using? I am going to use all these and I'm going to go one by one. First, as you can see, before I mention this, I'll go to this particular lecture slides. And let me just go to the architecture ones. So as I said, you can ingest data from all kinds of uh, devices. This is Kafka symbol, okay, Apache Kafka, Confluent, Apache. This is basically message pops up service, which captures these messages from the IoT devices. And you're going to, this is your Fabric Unified Data Platform. And we are looking at real-time intelligence service. Okay. And as I said, this is SaaS, right? Software as a service product. And you have one lake, which is the storage layer, SaaS data lake, which is software as a service data lake. You don't have to provision any infrastructure. All you do is just write those tables there. And it's all low code, no code solution. So we're focusing on real-time intelligence. You're going to ingest within real-time intelligence, you're going to ingest the data through event stream service. Okay, so event stream's purpose is just capture the events from Kafka, Confluent Kafka, operational databases like Azure SQL DB or SQL Server on Azure VM, those change data capture, Cosmos DB, which is worldwide, CDC is from Cosmos DB as well. And this is Amazon Kinesis. Kinesis is also similar service for high volume time series data capture. These are all again like message pumps up service, like it's just capturing the messages and publishing it, and the subscriber is like this event stream, it's going to ingest the stream, whether it is CDC event from all these operational databases, many more. I'll show you how many more. So event stream is the service to ingest the data and to process it. What kind of processing you can do? You can do all kinds of processing, like filter. Like when you are a SQL person, you write SQL query, you write filter, where condition, you write aggregate, group by, min max summary. You do what else? Aggregate, group by, filter, where conditions, expand. You do actually, if you have a array, you want to flatten the array, right? Like I'll just an array and flatten those type of expand processing, and I'll show you all those as well. So basically, you do process. Now this service is just to capture it. It's not for storing. It's not a storage service. It only stores limited data, maybe 7 days. And then the storage is actually event house. So like the house meaning it's again a storage engine, which is for high volume, high velocity time series data. It is columnar compressed storage and extremely blazing fast for this type of data processing. This event house is the new name within Fabric of the service behind this is actually Azure Data Explorer, which is the veteran service. And that service is renamed as Event House within Fabric, real-time intelligence. Okay. So this is your storage. You store the data, you ingest it, store it. And as you ingest it, because we are talking about data in motion, we want to act on the data in a very faster fashion. Suppose this is a banking transaction. I want to detect a fraud. Then you are going to need a kind of alerting service, like a trigger, reflex layer. Like as soon as this transaction is identified as anomalous, but or in our fleet operation, this particular fleet is going to fail, then I'm going to send a text, send a message or a Teams notification, or there are several options, and alert somebody, or send a Teams message, or send an email, or trigger a downstream pipeline through this activator service, which is kind of a reflex layer. I can also use KQL, Kusto query language, which is similar to SQL, which is nothing but I'm ingesting this data, I'm storing it. I need to understand this data. Through this service, which is KQL queries, you are going to analyze, explore the data through Copilot as well as through your own KQL queries. Okay. You can use the real-time dashboard to visualize this data in motion. This is much closer to the event house data. So it gives you much like a round chart. All this time series data is like, look at the how the data is flowing. If you want to detect anomaly, there's a spike, that's an anomaly, right? Beyond certain threshold. So those type of charts and visualization, geospatial analysis you can do with the real-time dashboard. It is very much capable, equivalent to Power BI, but Power BI is for much more complex, visualizations. Because Power BI as a service been there for a long, long time and had been widely used. Microsoft is trying to implement all of the features and visualizations that they have provided in Power BI into real-time dashboard slowly, and it's getting there. Okay, and then digital twin builder is basically to create a digital representation of your physical infrastructure. Suppose you're a manufacturing company, your assembly line, how are the different assembly conveyor belts that is processing the automobiles, and like I want to create a blueprint of that as a digital twin of my physical manufacturing plant. And that is why would I do, because I want to understand and make sense of where is different data point getting generated, where do I need to intervene. So the digital twin builder is part of Fabric IQ, which is giving you the ability to create business data model digitally within your data ecosystem in Microsoft Real-Time Intelligence and Lakehouse and Fabric. Okay, and Real-Time Hub is a like a one place to search all kinds of streaming data within your enterprise. So this is kind of a cataloging of streaming services. So any streaming service can come here, whatever, depending on your access, you want to see all those services that you have access to. One lake is the unified data lake storage layer. Now, this is a different storage. This stores the data in columnar compressed format. Okay. One lake stores the data in Delta format, which is also open columnar data layout. But then this is for all the services, like you have your SQL endpoint, if you have your data warehouse services, if you have your lake house, which is storing the tables in Delta format, and then tables are actually stored in the one lake. So this event house tables, you can decide to convert them to one lake tables. Why would you do that? Is because one lake is that unified lake. Everybody can tap into that lake and read any tables. So like that is the common format. It could be right now it is Delta, but I'm sure Microsoft is also going to enable for Iceberg and other layouts, other I believe it is already, if I'm not, I might be, yeah, it's probably enabled for both Delta and Iceberg. So you want to convert your event house table to one lake tables or Delta tables so that other services within Microsoft Fabric can also be able to join to those tables. Okay. And Power BI is there for you to connect to these event house tables with the direct query mode to be able to do visualization as well. Now, I didn't see data agent here, but you will see data agent. Data agent is also a service sitting there. As the event house data is getting stored, you can connect those data to the data agent or operation agent, and the agent will automate recommendations, intervention, and act on the data through Copilot and etc. Okay. So now I'm going to go to the demo back again. Much time I have? Oh God, I have very little service. Okay. So now I'm going to go. So I simulated similar fleet operation with these services. First thing is I notebook. I'll show you the notebook. So this is a Python notebook. Okay. Why do I need, see, I'm not connected to this is a demo, right? I created a simulated fleet operation. I'm using Event Hub as the protocol to ingest the data. So I install Event Hub. Then I have this command cell, which is creating the vehicle telemetry, like vehicle ID, route ID, depot ID, driver ID, geospatial location, latitude, longitude. I'm creating kind of like assume like I have 3 fleets operating, and these fleets are continuously emitting telemetry. Like these 3 trucks are going around just as a small case demo, and I'm capturing their telemetry. Okay. So I'm basically through some sort of a logic, I'm here in this notebook. I'm simulating what kind of, what would I get? The timing, route ID, depot ID, all of this, I'll show you. This is kind of a JSON payload, key value pair. And I'm generating these functions. And then after that, I'm actually starting this event capture. So I stopped it. I just did it a little while ago, around 1 hour ago, and I stopped it, but I can restart it. Is again, if I say restart, it's going to continue to generate new stream event, and it's doing it now. Hopefully, it didn't have a like I don't have to run the previous few cells again. Yeah, it's so you can see it's simulating this time series data. Oh, okay, okay. Yeah, so I need to run all three. See what happened is because I ran it about an hour ago, it kind of disconnected. And now I'll have to rerun the other above two command cell in order for the telemetry to get generated. So this is installing the event hub. Now, speaking of event stream, okay, it's going on. Now I'm going to do this one and I'm going to do this one again. And it's going to start generating. Okay. Now, one more thing. So you can see this connection string and event hub name. These are how I'm connecting this notebook to the event stream. So again, this event stream, this is a kind of flow diagram showing, right? So you can see this is my event stream service. I'm ingesting it from those notebook. The notebook is connected to event hub. So this is the custom endpoint. You can notice, like I was showing you, I'm using the event hub protocol. If you go to the SAS key, it shows you this primary key. You can actually see this. And then the connection string, right? And then the event hub name. So you copy this event hub name, copy the connection primary string, paste it to the notebook, to these command cells. That's how I'm connecting this notebook, which is generating telemetry. If you notice, the telemetry has started to generate. It's running right now. It's continuously coming. See, this is now. And if I go here, I click on this service, I can see the same ones flowing here. It'll auto refresh. So this refresh button, it's showing you the stream is coming in. So this is that data. It's a JSON payload, event ID, event timestamp, pass that fleet ID, which route it is operating, what depot it is close by, or what depot this is from, what's the driver's identity, geospatial latitude, longitude, etc., etc. All of those. If you want to see, let me see. Yeah, show the details. And you can, yeah, I'm going to pause this and it'll keep on flashing. It'll auto refresh. I can manually refresh, but if I want to not wait, I'll manually refresh. It's loading the data. This is the fresh data coming in. So this is 16 today. And this is the same thing that is getting generated from here. Okay. It's just continuously emulating the string. Now, this is that event stream service, which is this one. Okay. So the event stream service is actually ingesting, and this is from the custom endpoint. Now, what are the other services that we can ingest the data from? I'll show you that also. But before that, let me finish up this section. So event stream captures the stream. And if you go here, if you go to the edit mode, you can see that you can do all kinds of transformation. You can do filter, you can do aggregate, join, group by, union, expand, etc. Okay, so this is like as the data is getting ingested, you want to do some sort of a transformation. And then you can send the data to the event house to store it. You can also set up an alert with the activator. You can send this as a downstream, another derived stream. You can store it in Lakehouse and whatnot, and send it to a custom endpoint and everything. Okay, so I'm going to go back to the viewing live mode because that's when I can see the data. So in my example, I'm ingesting the telemetry from here, and then I'm going to set up activator alert to say activator is nothing but rule based on this combination of signal going outside of threshold. I'd like to notify somebody, the supervisor of the particular truck or the operation. And then I'm also going to store it to the event house. Okay. Now let me show this particular event stream service again to you. So as at this point, I'm actually this one, and I showed you the event house. I also showed you the activator. So it's like these two branches going in. Okay. So in event stream, if I go back, I can go to the here. Let me see. Yeah, you can go to the workspace, and let me go here, and you can say I want to create a new event stream, new item. When you say new item, now this is again live. That's why it's at the mercy of the internet. So I favorite, I added to my favorites all the services that I've used in this demo, like the activator service, like this is the monitor data set query and event stream for patterns to trigger action. The data agent, as I once said, this is the AI agent, builder, GenAI agent that understands your data, can answer complex question. So this is, you will see, it's a conversational analytics of your data stored in your event house and in your lake house and in your ontology and whatnot. Okay. And then this is that event house. It's rapidly load structured data, like it could be change data capture coming from SQL Server, which is structured, or unstructured data or semi-structured data, like your IoT devices sending JSON payload. The example that I have done in the demo. And streaming data and query. So this is your exploratory data analysis of those type of data. Event stream is capture, transform, and route the real-time event. And this is that icon. Okay. KQL query set and whatnot will go. So you select event stream now because I want to create it. Okay. So I'm going to say, let's say this is Pune. So I'm going to just say Pune, say create. And it's starting that service instance for you. And just give it a minute. This is important. I want you to see because I've built it, but I want you to see what are the possible connections. So there are three categories. It's saying connect to a data source, use some sample data. Microsoft has created some sample data so that you don't have to go hunt for some, say, if you want to practice, or custom endpoint like I did. Okay, so when you say connect data sources, what are the possible data sources that you have? Here it'll show up all of them. Select a source. Okay, so if you say view all sources, you can say so many. I talked about like alphabetically, if you go all, Kinesis, Kafka, Blob storage event grade, Cosmos DB CDC, Event Hub, Data Explorer, Azure Data Explorer also emits telemetry that also you can ingest. IoT Hub, so many. SQL, Azure SQL in managed instance, CDC, Azure SQL DB CDC, anomaly detection event, can have capacity overview event, like anything that is happening within the cloud infrastructure. That also are like maybe workspace item creation event or storage account creation event, Fabric workspace item event, Google PubSub service, or even HTTP. This is for like a REST API to get data from public feeds and software as a service sources, or even job events. So you can MongoDB, MQTT. MongoDB is another, NoSQL database. Their CDC you can capture. MySQL, PostgreSQL, mirrored databases, one lake events, like anything happening within the one lake, or Oracle's DB series. These are some of them are actually preview items. You can see preview means it's not really generally available. MQTT is pull data from your, it is message, queue, transit, forgot the last name. But anyway, so these are all the different services that you have. And if you click on this, it kind of categorizes. You can also see public feed. Public feed, as I said, like weather. Every company needs weather data because if you are trying to do this stuff operational at least you need to understand the weather. So you're going to get that very quickly, the weather data. This ingests the live weather data for a selected city into event stream. Okay, so you can see how many sources it is already configured. These are low code, no code connector. I can just say click and click, 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 or even you can use through, you can generate these as a, like when you are promoting this code from one environment to another, you can also use, YAML and API as well. But right now I'm going to, like, as you can see, I'll skip these steps. You can say connect and go through few steps. It's going to enable you to ingest the streaming data, the weather data into through the event stream into your into your Fabric real-time intelligence platform. So I'm going to close this one. I'll go back to where I was. And there are also some sample data. If you want to learn, suppose like bicycle data, this is very common. You'll see a lot of people have created demo with this. There is also yellow taxi data, like the taxi telemetry, stock market telemetry, buses telemetry, S&P 500 company stocks, semantic model logs. Like Microsoft is doing this to help others to learn because you can use this sample data and explore your pipeline, build your pipeline, and get your hands dirty. Okay. So with that, I'm going to go back to that event stream service that I was going through. So in this case, oh, this is real-time intelligence dashboard. In this case, I ingested the telemetry, right? This is my telemetry payload, and I'm storing it to the event house. Let's go to the event house. Event house is that optimized storage layer, which is columnar compressed. You can see the compression ratio is very high, and it is showing, it's kind of like a visualization or dashboard to show the event house. It's almost like a SQL Server instance. And then within that, there could be multiple databases. So even how is that instance? And then within event house, you have multiple KQL databases, like I have two. Okay. So it's showing what are the activity, etc., and which region, all of those things. Okay. And as I said, this is gives you blazing fast performance and storage efficiency as well, because it's columnar. The data is stored in columnar fashion and it's compressed. So it helps in performance as well as it helps in um, storage cost as well. So that's that. And you can have multiple databases created. You can create new database with this plus sign. I already have the database and I'm going to go to that database. Um, Let me just see database, yeah, KQL database. So the database view is I'm here in this particular KQL transit operation database. I've stored that fleet telemetry data. So you can see freight law telemetry. This is live data coming in as of now. By the way, I have to go back to the notebook and stop it. Otherwise, it's going to fill up too much telemetry because I'm generating very fast. Let me go and stop this now. Okay, so I have enough data to show you, so I don't need any more. Next, go there, KQL. Okay, so just to see how the data look like, this is that JSON payload. So remember event ID, event timestamp, vehicle ID, key value pair. JSON is semi-structured. Okay, key value, route ID, GPS location, latitude, battery temperature, brake temperature, delay of the vehicle, ingestion timestamp. Those are the telemetry that you are ingesting it through this event stream and storing it to the event house in the KQL database. Okay, so now that is my table, which is storing this. And you can see it shows the captures, the activities. You can see this one leg toggle. Then now these compute, as I said, event house is Azure Data Explorer in the, that's the service which is event house under the hood. Now that stores the data in columnar compressed fashion for high volume, high velocity, immutable time series data. Now, if that data you want to be converted to delta table in one leg, you can enable this one leg toggle, and that will create a delta table in one look from this event house table, so that you can connect to that delta table with other SQL endpoints, other lake houses to do analytics if you need to. Okay, so that's that. And you can have multiple tables sitting here. You can, I'm just for the simplicity or for the time, oh my God, I have 10 minutes only. There's so much to cover. Praful, what we need to do is we probably have to continue this more on the next session and then another one for the agents, because I don't think I'll be able to complete everything by 10 minutes. 10 minutes we have, right? How much time do we have, guys?
If others are okay, we can extend for next 10 more minutes also. So if others are okay, I mean, others can speak up and they can provide their comments. So 20 minutes should be fine, more, right?
I am fine.
Additional
If
10 minutes.
everybody is okay, yeah, I think the demo I can cover in another 15 minutes. Is everybody is okay? Then I am okay. How about others? Okay, Hardik is saying good. Everybody good? Hopefully, I'm
Atit,
not overloading too much
yeah,
information in one session. Okay, yeah, go
Atit,
ahead.
yeah, maybe Atit, Naina, Saurabh, if you guys are okay, if you can provide your
Give
reaction
me a
on maybe,
feedback. Yeah,
yeah, yes, sure.
Atit. Okay,
Yeah, Atit
Nana.
said yes.
Okay,
Yeah,
thumbs up is good. Thumbs up is good. Give me a thumbs up if everybody wants to stay back a little longer. Subramaniam. Okay, let's proceed then. Okay, so I'll go back to that event house service. So this is my KQL database. You can store your tables here. You can also create a medallion architecture in this particular event house KQL database as well. Medallion architecture meaning you're like, as the data is ingesting, you're ingesting it the bronze layer, then you're doing some data quality rules and creating your silver layer, then you're doing some time bound aggregation and creating your materialized view gold layer. So that you can do. Just to keep it simple, I didn't do it in this case. I had another demo which has that example, but it is something that you can enable. You can do it. How do you do that? You basically create different named folders. Like this is my bronze folder, this is my silver folder, this is my gold folder, and you use update policies to flow the data from bronze to silver. And during that flow, it's going to do some sort of a duplicate removal, let's say, or null check or whatever it is that you define for data quality. Then from silver to gold, you're going to create materialized views, which is going to read the silver data, and on a time series based, like every 5 minutes, you're going to create an aggregate. So those aggregates, because this is a never-ending unbounded data set, right? So you cannot do aggregate for the entire thing because you're going to sit there forever to get the data coming in and never it'll stop, right? So you have to do it time-bound aggregates. Like, every 5 minutes, every 1 hour, I want to do this kind of a, whatever it is that I'm trying to do, min, max, average, etc. So that's you have the technical capability to be able to do medallion architecture here, and your tables are getting stored there, continuously getting ingested the data. You can also see the entity diagram. It kind of shows you how the different tables, like how is this flowing, the lineage, bronze, silver, gold. I have only one event stream to event house in this case, but if you have a medallion architecture build, they will all visualize here. Okay. And one more thing, in the workspace folder, remember I showed you also when I was, or I'll show you later, because if I switch, then it's going to take me more time. Okay, so this is your storage. And how do you explore this data is through KQL. So if you click on this is KQL query set. Click on this KQL query set. It basically shows you your queries. So just like you write SQL queries in SQL Server Management Studio or Azure Data Studio, SQL Editor, or those type of clients, here you are using KQL query set as the editor window to write your queries. KQL is Gusto query language, very similar to SQL. You're going to set table name, limit 20 or take 20, meaning select 20 rows from that table, top 20, etc. And you can put where condition, pipe separated, very simple syntax. Okay. And you can put additional conditions if you want to expand, extend. You're checking some more column condition, like break hot means the break temperature is greater than. So you're creating some derived column. And you're saying if this is greater than, then this is a new column which is going to be true for break hot, battery hot, delay in minutes, etc., etc. And then you're basically you're displaying those. Suppose if I run this, let me run this, and it's basically taking for one vehicle, creating some. Did it still running? Yeah. So for that vehicle, it's taking. These are the telemetry coming in, the temperature, brake temperature, battery temperature, delay in minutes, these are coming from the telemetry. And it depending on that, it's creating an incident score, a derived column called incident detected, which is when these three the derived fields that you created all are true, then it is a true incident. So like these are all false. But if you see, sometimes it's a true meaning this is more than 180, this is more than 55, and this is more than 8. So like if certain vehicles telemetry is needs intervention, so you're creating a derived column called, that's how it is. So now if you say I don't know see KQL, how do I write that? I can show you that Copilot can write you much more complex KQL without you having to know this. So suppose I have this natural language prompt, Control C, I'm going to open the Copilot, and this is the
Yeah,
Copilot window.
yeah.
Go ahead.
And meanwhile, Mo is showing this. So I'll just try to say, guys, whatever Mo is showing, the KQL, the event streams, these are the technologies which are used across multiple platforms. So I think Mo can also vouch for that. So
Yes.
KQL, SQL, these are the things that are going to be used a lot in the upcoming years. So start learning it. Okay.
Yeah,
Yeah.
yeah. Absolutely. So you are going to be so much better off. If you trust me, this service, streaming service, real-time intelligence is going to become so much more prevalent everywhere. Because everywhere if companies are building agents, they need fresh data. This is fresh data. You have to work on fresh data. You are gone at the days of batch world. Okay, so I said generate a KQL query to identify all vehicles with active incidents in the past 15, and this is natural language prompt. Okay, so I say run it. So it's working on it. This is again AI power, GenAI power. So the under the hood Copilot has OpenAI model running or Claude model running, and it's taking the text and it's generated a KQL query for me. And I can say insert it. So I can put it and say insert. Say it wrote it for me. Okay. So I can close this out and then I can execute this query. Oh, extend operator failed. So it did probably, let me just see one more time. I hope it didn't make any mistakes. And if it does, it's fine too. You can actually just feed in the information and see correct it. Okay, semantic error. So I'll go back, Control C. This is how you fix it. Good. If you have a error, not to worry. Go back to your Copilot and say fix this error. Huh? And then you put the error. Say this. This is the next prompt. It is revising the query, working on it. Okay. So now I'm going to take my cursor here and I'm going to say insert. It
Yes,
inserted
was please go ahead if you have any question.
and
Yes.
I'm going to run it. See
Yeah.
now
So
it sucks. It actually is succeeded. So it
Yeah, more.
initially.
I think Suhas has one question. Yeah,
Oh
Suhas,
yes.
yeah,
please
go
go ahead.
ahead. Go ahead, Suhas.
Yeah. So basically, as you mentioned, event house table, right? So we can convert that table to delta lake format, right? So can we use then later like SQL queries like SQL type
Yes, even
queries to
yeah, yeah, 100%. So here's I didn't mention you. Even in KQL editor, you can use SQL. You can write SQL. If you are not familiar with KQL, you want to use SQL, you can do so too. So
okay,
again,
okay.
this query it wrote, and it did I yeah this one. Sorry, run it. So it's basically trying to as I stopped the telemetry, so it's not showing me any output. But if I go back to my notebook and I start the telemetry, hopefully I will not be able to run, start the telemetry. That KQL query will start getting out. See, I started it again. Now, if I go back to my event house KQL database, should be able to see. If I wait over a little minute, it should show up. But yes, if you want to run SQL, you can run SQL also. You don't have to be just KQL. You have your Copilot to also help you with query writing. Okay, so that's your analysis area, like basically exploratory data analysis. But as you run these queries or create these queries, you want to visualize them, right? So how do you visualize? Let me just see one. Let me run this one of them and I'll show you how to. Okay, so let's see this one. No, because I'm running this, so it's going to continue to coming. Yeah, so that's fine. Now this is tabular format. It's selected automatically. You can add other visuals. If you say add visual, it'll tell you what type of visual do you want to select. You have bar chart, column chart. These are again real-time dashboard, time chart, pie chart, area chart, etc., etc. Suppose this is something I want to do. Let's say column chart. I'm just showing you how these things works. And you say column chart, obviously you have to select what would be the title, what would be the x-axis and y-axis. Okay, so I am going to show you what I've already built. It's hitting some limit. I'm in the demo workspace. Let me stop this because otherwise I'm going to incur cost. And then the admins are going to have to come back to me and saying that you have consumed and more. Okay, so now I'm going to, as I showed you, I was trying to show you how to visualize this, right? So I have a query. I can pin the query so you can see save to a dashboard, the output that I generated. Let me just do this simple one. Okay, so now I can save to this is a tabular representation. Similarly, I can do all kinds of visualizations. I can save to a dashboard, to an existing dashboard or to a new dashboard. Okay, I can create a brand new one. Now, speaking of dashboard, I'm going to show you the dashboard, which I already have. This is one dashboard I've built, very similar to Power BI. You have multiple tiles. Each of the tiles are actually another query. So you can see I'm in the edit mode. This particular tile, if you click on the pencil icon, it's going to show you this is the query it is running. And it's a visualization is here. It's just a data. It's showing the count, right? It's a counter kind of visual setup. As I was showing you the all the other visualization, I'll discard this one and I'll go back to another one, which is the geospatial one here. Okay, if I click on this pencil icon, see this is latitude, longitude. It is presenting in the visual setup. You can see map visualization. Okay, and you can see the data. It is latitude and longitude columns are visualized. Okay, so like that's the idea. You have all kinds of charts that you can do. KPI, time series, these are new. Bar chart, column chart, these are older. Run chart, time chart, line chart, funnel chart, anomaly chart, etc. Heat map. Okay, so this is your real-time dashboard. It's much lower latency than the Power BI. Power BI dashboard also you can build. Like if I go to that KQL database, and then here, you can see there is a Power BI report connection. So if I go, let's say, run, okay, and you can go to Power BI, hit Power BI. It's going to open up your Power BI workspace and it is going to connect to this data set and you can build reports there as well. So just skipping it for now because you probably know how to build Power BI reports. Those functionalities are all there. Okay. So it's opening up the Power BI and it's going to connect it to that poster query and you can visualize it or build reports here. Okay. So real-time dashboard, Power BI, both. Now let's go back. So this is the control tower dashboard I showed you. You can actually refresh this data based on your refresh requirement, right? Like, and you'll see if I go to the view mode, it also has Copilot. You can open up Copilot. You can talk to the Copilot. You can use Copilot. This is the AI power to be able to dig deeper into all the visualizations that you're seeing in the dashboard, real-time dashboard. Okay. You can refresh this data. You can add alerts also, trigger mechanism based on certain, suppose this counter goes above 100, you want to be alerted, something like that. You can also, if I go to the manage and go to the edit mode, you can also set up refresh frequency. Like if I want to say live refresh, I go to the, what are my limits? I can do 10 seconds as low as 10-second refresh for this dashboard. So it's like low latency visualization. Okay, cancel. Those features are there. Next is I'm going to get you to what else? Ontology. So as I was mentioning, I think I mentioned digital twin, but not ontology. Ontology is building semantic model on your data foundation within Microsoft Fabric. So if you're a Power BI developer, you create a data model within Power BI when you're building the report. So that's kind of your disconnected, isolated semantic model. Different Power BI developer can create different data model, right? Depending on their perception of the data. So you don't want that because then in that case, semantic model is distributed and it's almost like there's no single source of truth. You want that data model to be business semantic model to be created on top of your tables stored in the lakehouse and event house. Lakehouse are your delta tables, event house are the tables that is storing the streaming data. So that's that entity relationship diagram. So these are your tables are entities, relationships are how the entities are related to each other. Properties are what are the attributes of those entities. Just like you create a conceptual data model, logical data model, physical data model, in the older world for on a separate software like Power BI, Power Designer or Airwing. Here you are creating that business data model in the Fabric platform itself within your event house table and lake house table. The benefit is now you have a single unified semantic layer. So semantic model, and that consumers can connect to that model. They don't have to reinvent that model in their site. And it's a single source of truth. Also, because you are going to be build agent on top of this data, right? Agents are AI, LLM, right? They need to know which tables are the source of truth. Like in your Fabric data platform, there could be 10 different vehicle tables. Which one is actually the right one to use? The one which is part of the ontology, the one which is created as this knowledge graph like entity relationship data model by your team who are maintaining this, right? So if agent is been connected to this ontology graph, the knowledge graph, then agent knows exactly which vehicle table is the one it should use. And it doesn't have to think, it doesn't have to search 10 different tables and assume and guess and everything. So performance will be faster, cost will be lower, and accuracy will be better if you have this semantic model. The knowledge graph. Graph, why? Because nodes and edges. Like here, this is an entity. This is another entity. Okay, and if you see lead 3, you can add properties, you can add relationship. Like if I go to this one, this is the vehicle assigned to a depot. A vehicle belongs to a depot. So vehicle entity, depot entity, they are related by the depot ID. Depot ID is the primary key. Vehicle ID has a vehicle ID is the primary key, but here depot ID will be sitting in the vehicle as a foreign key or a related column, and that's how you're joining them. And if I go back, I don't want to delete. I go back. And similarly, if you go to this entity, no, not on the relationship. I want to click on this. You can also click on these 3 dots, go to manage rules. You can view the rules that you are going to define in your business. So you can define the semantic model, you can define the rules, like the logic, how an agent should process the data. So the policies, these are your rules. Like you're saying, these are the conditions which means this is a high priority route. These are the conditions which means whether the replacement vehicle is available or not. So why would you mention these things? So that agent doesn't have to assume anything. See, LLM brain can hallucinate, can decide on their own how to process the data or give the answer. Rather, you are telling deterministic policies. This is how. When you provide these policies through the ontology to the agent, agent's response will be exactly how you want it to be. So you can control the response and determinize the responses. Clear? So that's your ontology, which is your knowledge graph. Nodes and edges that you build on top of your lakehouse tables and event house tables. Now, last is I'm going to show you the data agent, okay? Because I think we are coming close to the time. I don't want to make sure that I'm not crossing the time. Everybody good to still continue with the time? Yeah, okay, fine. So I see everybody's here. So we'll another maybe 5 minutes or maximum 10 minutes. Huh? By the way, I will work with Proful and I'll come back again. So there's so much to share. I just didn't have enough time to cover everything. So if you're completely studying, see, as a teacher, when I teach, the biggest problem I face is when the students are completely starting from scratch, because then there is so much to cover. I can't just jump to the Z unless I go A, B, C, D, right? So that is the challenge. Okay, so now next is, let me go back to the data agent. So that when you build a data agent, what you do, you are going to tell that, okay, agent, these are the data sources. This is each data source contains. This is the tables. This is the definition of these tables. These are the meaning of the columns. This is the graph, ontology, logical data model, semantic model. This is the policies that you need to follow. And then you teach the agent. You basically tell the agent, like, this is all of your fact, all of your data from the enterprise. Now, if somebody asks questions like this, then you should answer this way. So you're guiding the agents. Again, this is natural language. You're not writing any programming language, but your agent is having that intelligence through the LLM brain, and it's getting the context and the data from your data that you are providing it. So first thing, when you are building an agent, you have to add data. You can add lake house, event house, can add AI search as your AI search. Why would you add search? Is because if you are working with ChatGPT or Claude, you probably know that it's not that your LLM, like your LLM needs facts and information. Your enterprise data will be there, but sometimes you may have to search internet or web, or go reach out to the web search, or even within your enterprise also, you may have to search multiple sources. So that's your search capability, discoverability. Okay, so you can also add data. So in my agent that I've created, FDA transit operation incident, I've added this um, KQL database. So you can add up to 5 data sources. Within this KQL event house, I have about multiple tables. All the tables are allowed, or you can select whichever you want. Like I selected all 4. I can basically pick and choose which one I want to give it to the agent. Don't give the entire data event house or entire lake house to the agent, because then the agent will have too much information. You want to be focused, targeted niche agent, right? They can, so that they are responsible to be much more accurate. So you give the specific tables, you give ontology, because ontology is how the semantic model. The agent who needs that information to traverse the graph, the knowledge graph. You set up the agent with instruction, like you give agent instruction. In this case, like if so you're saying you are a fleet operation assistant, intelligence assistant, and for the command center, these are your data sources. This is your data source. This is your ontology source. These are your incident. How do you decide an incident? Is these 3 conditions? These are your ontology policies. Ontology has 3 policies. When answering questions about this, you're basically instructing the agent with English language. You can also give data source instruction. You should give. You are going to explain the agent what data each table has, why would they be needed, when it should look into those tables for what questions, etc. So data source instruction and all of those information. You can also give example queries. Example queries is like you're teaching the agent. The LLM here in this case is natural language to KQL, or natural language to SQL LLM running. So it's going to take the natural language prompt, it's going to convert it to SQL, and or KQL, SQL KQL interchangeable. They both are same, okay, or similar, but 2 different dialect can consider. So you can write, this is my natural language question, this is the KQL query. You can generate this with Copilot and paste it. So you're teaching the agent, giving some examples so that it can generalize, it can be able to create more or answer future unknown questions. Okay, so now that's how you basically prepare. You can also use tools. I didn't add any tools. Tool calling is code interpreter tool or any other tool. Let's see, there's a sound coming in. Okay, so now last thing is so these are, as an author, you need to set this up. And then once it is ready, you are going to publish it. Okay, once you try to publish, it's going to ask you. So you give a name, a user-friendly name, a description, purpose of the agent, and publish to, you can also publish it to agent store in Microsoft 365 Copilot, so that when you go there, you can see this agent sitting there and you can ask it. So suppose you create this agent for a particular event house data. You can consume it. You can provide this agent as a consumption interface in the 365 Copilot. Okay, so that's that. If you enable this, then you can publish it. I already published it. So revert to published version. I'll go to the published version. And now you're going to, again, you can close out these queries that I was opening up. And you can see the previous chat. You can start from sample questions. As you added some example queries, right? Those shows up. So like, what are the historical trends I'm saying? And you hit this and it's going to give the answer. It's going to answer from your data that you have set up here. It's not going to answer from like internet data. So
I think
that's the.
Hardik has a question on
Hmm?
this. Yeah, Hardik.
Go ahead.
So basically, my question is on KQL instructions. So as we know, like for agent instructions, we are having some characters limit, right? So for KQL also, we have any limitations, and if yes, then how we can overcome that?
So I didn't hit the limit. Uh, how have you ever encountered any limitation? How much was the limit that you? There is no. So
Yes.
again, these are again soft limit. Say add the data, guide the data agent to the base data sources, like the data source instruction. There could be some character limit. If it is a character limit, then again you can use another copilot to concise it, make it shorter such that you don't cross that limit. And again, these are soft limit. If you could reach out, they can probably increase the limit as well. I would say give instruction not too long. Don't give like a dump of a document here. You have to give it
Mhm.
very precise. This is your role. This is the tone. These are the sources. Because it has that brain to get the intelligence out of it. You just give the facts that it needs to know, that it may not know based on the LLM's training data set. Okay. So
Okay.
hopefully that
Perfect.
helps, and go through that learn mode and try to go there. Anyway, whereas yeah, agent instructions, I believe I clicked on the, yeah. So let me go back. Oh, sorry. Yeah. So I was asking these questions, right? So let me close this out. Yeah. So I asked this question, and you can collapse this section also. Historical trained. Okay. So it is saying that it is not. So maybe analyze the KQL plus to summarize. It couldn't able to do it for some reason. Is the compute not there? Let me just try again. Otherwise, I'm going to show you one example that I already have captured. Because sometimes when you are doing a live demo, because I don't have the streaming
Yeah,
notebook,
Subramaniam,
I've
you
stopped
can
it.
ask your questions. Yeah.
Yeah, so
Subramaniam
it's
has a
doing it.
question.
It's doing it. Hold on. It's doing it. So first time it is actually, yeah. So it's answering it. So it's completed. This is the natural language narrative answer. And if you click on this arrow, you can see it analyzed KQL, show historical data. We expand each of them, shows you the query. And the query shows the result in tabular format. But when it responds, it doesn't give you a table. It gives you a natural language. And you can review see how much complex query it wrote. You can review the query and instantaneous, like it's so much blazing fast LLM power you're getting. Should utilize it. Okay. Query. And so you can take a look at how it is answering this question. And then finally, if I minimize that whole expansion that I did, so you can collapse these arrows, and you can see it just came up with this show historical trends, and accordingly it answered that fleet telemetry. There are technical issues retrieving. Okay. Historical data is not coming because here I am a demo environment, right? It's not a live. I just once in a while, whenever I'm doing the demo, I turn off, turn off. So that kind of is intervening, yeah, like, interrupting with this processing. But I do have one recording, which I will show you real quick. That is, demo, this one, right? So 5 more minutes. I know I said 5 minutes, but I went probably 10 minutes. And let me just go here all the way to this end. Okay. Okay. See, it answered the questions. I'm sorry. I have to share the sound. Give you these historical trends. Okay, you can see how, and the agent generated output can feed into an action layer. Okay, so what are the historical trends in the data? It gave you these historical trends. Okay, you can see how it came up with the answer, the plan, and then the corresponding KQL query, and then the output. And then finally, it gave you the answer in natural language based on the query output, right? So it didn't give you the tabular structure, it narrated the answer. Similarly, I'm asking, it's conversational, or you can add follow-up questions, recent data for any outlier. So based on that, it is giving you answer. So this is how it goes. So you can see, you can work with this, play with this, and you'll see it gives really, really deep. Okay, so that's, and then one last thing I'll show. I think I forgot activator. Sorry, I think I forgot activator
Maybe
to
we can
show.
have a separate session for activator also, Mo.
Okay,
Okay.
okay.
I think
I think
we can
we
cover a
crossed the
different
time
demo.
limit, right?
Yeah.
Okay. Yeah,
So we
yeah,
can have a
no
separate
problem.
session. Anyways, we can cover with activator and data agent, and then we can cover it. But yeah,
Sounds good.
yes. If anyone has any question left, Subramaniam, maybe you can ask question to Mo directly. You can connect over LinkedIn also, or you can
Sounds
go through
good.
it. Okay, or you can
Thank you.
pass the question to me. Okay. So thank you so much for joining today's session, everyone. Yeah. Have a good evening, and Mo, have a good day. Bye.
Thank you, everyone, and we'll see you soon. Next session next week. Bye, everyone. Take
Thank
care.
you. Bye.
Thank you. Bye.
Thank you.